Hello, my name is Maciej, and today I'd like to share some insights on the impact of the kinematic structure on the force displayability of planar passive haptic devices. Passive haptic devices are known to be difficult to control. Their force output direction depends on the velocity direction of their actuators. The relationship between the velocity of the end effector and the velocity of the joints is dictated by the kinematic structure. Therefore, we wanted to explore how the kinematic structure affects the ability of passive haptic devices to display forces in arbitrary directions. To this end, we modeled and tested 9 manipulators, 3 serial and 6 parallel, with varying link-length ratios. The ellipsoid on the right represents the manipulability of the manipulator divided into displayability regions. Device's ability to display a force depends on the location of the force in the ellipsoid given a velocity of the end effector. If the desired force is within the green region, it can be generated using both brakes. This is called a fully displayable region. In the blue region, the force can be approximated using one brake. This is the partially displayable region. In the gray region, the force cannot be generated at all. Note that as the device moves through the workspace or the velocity direction changes, these regions will change shape and size. To evaluate various kinematic structures, we calculated the fraction of relative workspace area where a force is displayable given a velocity direction. In this sample simulation, we can see the areas of the workspace where a force can be displayed as a function of angle between the desired force and the input velocity. The change in size of these regions is shown in the graph on the left. This approach is the basis for a set of guidelines for the design of passive haptic devices. Serial manipulators perform equally well irrespective of their link-length ratio or the velocity direction. As a result, these manipulators are an excellent choice for general-purpose haptic devices. The performance of parallel manipulators with base link length of 0 is also unaffected by the end effector velocity, but the link length ratio is a significant design factor. The manipulator with equal link lengths performs the best compared to other two manipulators, and equally as well as any serial manipulator. As a result, this manipulator is an alternative to serial manipulators with the added benefits provided by the parallel kinematic structure. Finally, the performance of parallel manipulators with base link length of 1 varies wildly depending on both the direction of velocity and the link length ratio. Of the manipulators modeled in this paper, the one with first link shorter than second links performs the best, as in some directions it can generate the desired force in nearly all parts of its workspace. As a result, this type of manipulator is best suited for specialized applications where the user moves primarily in one direction. The approach proposed here can guide the design of passive haptic devices.